The Red Planet, a planet bearing the name of the Roman god of war, a world that has captured scientific and general minds alike in recent history and beyond. That planet is Mars. It is far, barren, and would kill any exposed humans to its atmosphere and climate within minutes. Yet it still draws expeditions and missions like no other planet within our solar system. NASA's successful landing of one of their rovers, aptly named Ingenuity, must have felt as electrifying and significant as the Wright Brothers' milestone in flying the very first machine-operated airplane. Their mission? To uncover the secrets Mars had kept hidden from humanity and tap into yet undiscovered potentials and opportunities. How? By collecting samples from the source and analyzing them. Sounds simple enough, right? Well, think again. Let's rewind a little and start from the beginning. So, what did NASA expect from their gargantuan exploratory mission to Mars? How did it all start? And what would their modus operandi be once on the surface? Let's find out. The aerospace sector has been steeped in fierce competition ever since humanity's first step of defying Earth's gravity and eventually leaving it behind altogether. This led various organizations to duke it out for dominance. NASA also heeded that call and has shown that it could accomplish incredible feats and fascinating innovations. Like NASA, many similar agencies have thirsted for grander and more exemplifying accomplishments, and thus all turned their gaze toward Mars, that mysterious planet that could possibly house new life outside Earth and make it an irresistible and obvious choice. In February of 2021, NASA managed to write history when it launched Ingenuity, the first spacecraft designed as a helicopter. It successfully landed on Mars and completed several test flights in quick succession. You'd think the landing would already be a considerable challenge. Still, the scientists were not done by a long shot and turned their attention towards the possibility of discovering existing life on the planet. The devil is in the details, as one might say, and it is no different from conducting detailed soil composition analysis by collecting samples. How did NASA plan on doing that? Enter perseverance. Sure, NASA certainly needed a bucket load of it, but we are explicitly talking about a spacecraft here. Its primary purpose is to drill into rock and soil and extract valuable samples in specialized containers or tubes. This process is known as sample catching. NASA planned for the missions to bring the collected samples eventually back to Earth and simply called it Mars Sample Return, or MSR for short. These examples would then be subjected to extensive studies, which would be impossible from such vast distances. The demands and challenges are many and strain budgets, logistics, and minds alike, but many realize the potency of completing the mission successfully. It goes as far as being described as the most critical use of robotics since it could unlock a greater understanding of what an actual manned flight to Mars would require. No pressure for such big dreams, right? Speaking of big dreams, they all have to start somewhere. The 2020 Mars project was the cornerstone and the first proposal to establish Mars' viability for exploration. It planted the seed for future scientific missions and groundbreaking innovations to collect, analyze, and harness the mysteries of the red celestial phenomenon. A phenomenon? Wait, how? One area of interest is to determine both the physical and chemical composition of Mars' soil. Let's take a closer look at that, shall we? The actual procedure is incredibly complex, but lucky for you, we will attempt to break it down into several steps. First, the rover must carefully collect samples from the surface. The necessary equipment is encased with the rover's belly together with a drill carousel device. The device is shaped like a wheel, with differently sized drilling heads and 43 tubes waiting to be filled. The onus collection is given to a massive robotic arm, while smaller version secures and seals any materials unearthed by the big one. Like the song title says, smooth operator. Any type of cross-contamination between Martian and Earth samples must be avoided with great care. Strict adherence to protocol and regulations is of paramount importance, which extends the setup of the rover itself with organic, inorganic, or biological materials during its use. NASA thus decided to mount 5 additional witness tubes to the rover. Their sole purpose is to capture and contain any contaminants or impurities emitted by the rover during any operation phase in the form of gases or exhausts. They sure don't want to start on the wrong footing, even if it is for the time being a figuratively speaking footing. If used, they would be treated like regular tubes and brought back to Earth for further study. Still with me? Good, because there's more. And we've merely covered step 1. Onwards to step 2, which is storage. Remember the small robotic arm mentioned previously? That's it. That's the arm that handles any filled tubes, seals, and stores them. Once sealed, it cannot be undone until the rover operators of the craft decide to drop off the samples at a designated location. Step 3 is the actual drop-off of the samples, where they can be hopefully found again. Or that is the idea at least. The operators decide on a specific spot that marks the X or the temporary cache for the samples. The samples will remain there until they are picked up and sent back on their journey earthbound. You have to know that all the above at some point was just a bunch of ideas. Some great, some less so, and some, well, not even worth mentioning. Engineers, scientists, and mission planners spent countless hours trying to develop a solid concept for missions that would bear the best chances of success, but somehow never made it past the implementation phase. Fast forward a bit, and 2020 saw the launch of Perseverance in early February with a successful landing inside the Jezero crater. NASA specifically targeted that crater because it was thought to have once been an ancient lake with very fertile soil for sampling, or so they hoped. Water usually means the possibility of life, and if so, it would further strengthen the possibility that life may have once existed on Mars. In August of 2021, the first attempt to drill into the Martian rock was made. The intended hole was about finger size, so technically not hard to do, right? Mars didn't think so. The initial attempt failed because the rock turned out to not be solid enough and thus crumbled onto itself during drilling. Undeterred by the setback, the operators decided to send the rover to more favorable ground to continue its mission. On August 5th, after the operators have given the rover its final commands in the evening to commence drilling, they discovered the following morning that the rover had managed to drill a hole as expected. So far, so good. They then verified recent images and confirmed that the tubes had been filled with Martian soil. But when they cross-referenced their data, they discovered that the tubes contained nothing. You can probably imagine the operator's disappointment when everything worked as expected. No malfunctions or issues had been detected or reported. Months of preparation on Earth had nonetheless failed to highlight one crucial fact. Mars was unlike Earth. It was a hard but necessary lesson to learn to repeat the do's and avoid the don'ts going forward. NASA was confident that whatever worked on Earth would likely bear success on Mars as well. Who can blame them? Not like anyone ever set foot there yet or provided a manual, so they did as they thought would be right by drilling holes into the Earth's soil that were actually smaller in size than those on Mars. And the tubes would be consistently filled with material. Brimming with confidence, albeit misguided, they anticipated having the whole operation wrapped up within 11 days. It's not all doom and gloom though, since failure always contains the nucleus of fortune, and NASA is already planning for new drilling attempts in September. In any way, shape, or form, persistence and grit will have a tremendous impact on understanding the differences and challenges that Mars throws at humanity. Who knows, perhaps one day in the not-so-distant future, that which has captivated so many in books, movies, and mere imaginations could finally come true. The reality and possibility of a crewed mission to Mars, and repeat the exact same words that Neil Armstrong once said when he set foot on the moon. If you found this video informative, please consider hitting the like button and subscribe to the channel.